All right, so we're graphing this problem using Desmo. So we've got x plus 2 raised to the power of 3/2, which is 1.5. All right, so when we look at this graph, what we're looking for is whether or not it's approaching a specific value of y. And you can see this is continuing to increase. So I'm not seeing any sort of asymptote on this graph. So it's asking if there's an asymptote at a equals -2. So graphically speaking, no. But again, the easiest one way to really clearly look at that is, or algebraically look at it is, oh, whoops, I don't know what I'm doing here. Bear with me. Plug in -2. What happens when you plug in -2? Well, you get 0. It's not undefined. If -2 were an asymptote, the graph would be undefined at that point. Okay, so that's the same method for each of those. And then for questions 9 through 16, you are evaluating what happens when your graph approaches infinity. So let's do one similar to 9, but not exactly the same. So let's just say 1 over 6x plus 8. We're looking at the limit as x approaches infinity. So think about that. As x gets really, really big, this number in the denominator is huge. It's basically approaching infinity. So 1 divided by infinity is going to approach, it won't equal, but it is going to approach 0 because you've got 1 divided by a really big number. Another method for solving these is to just graph them and see what happens as x is getting bigger and bigger and bigger. So, and let's do another example. So let's say 5x minus 6 over 7x. So the limit as x approaches infinity. So a method here, when you have a rational function, one method that makes these problems a little easier if you don't want to graph it, is look for the highest exponent and divide everything by it. So I'm going to divide everything by x, by x, by x. So, and you're allowed to do that because you're making sure that you do it to every single piece of, every single term within the equation. So you're not changing anything. So if I divide that by x, that goes to 1. That goes to 1. 6 divided by x. So now what we have left is 5 minus 6 over x divided by 7. And we're still looking at the limit as x approaches infinity. So as x gets really, really big, this goes to 0 because it's 6 divided by a huge number. So then we are just left with 5/7. And again, you can always confirm that by plugging it into Desmos and checking out the graph. So what do we have? 5x minus 6 over 7. So let's see what that looks like, just for the fun of it. So y equals 5x. Oh, goodness. Parentheses, there we go. Minus 6, close parentheses, divided by 7. X. I knew I was forgetting something there. 7x. So if you look at this, you can see as x approaches infinity, can see that fraction there, 0.695, which is going to be pretty close to 5/7. Oh, 0.706, 0.707, and see that, 5 divided by 7. Look at that. So you can see that, yep, it is indeed approaching 5/7. In questions 17 through 19, so, whoops, what's going on? Oh my goodness. Struggle today. In 17 through 19, you are asked to find the vertical asymptote. So we talked about that earlier. In 17 through 19, 17, 18, and 19, you have, again, rational equations. So let's just look at an example. We won't do the exact same one, but we'll do one similar. Oh, because I want to be lazy here. Let's make that a 4. This is a rational function, so your vertical asymptote is found by looking at the 0 of the denominator. So we simply set 4 minus x squared equal to 0. So negative x squared equals negative 4, x squared equals 4, x equals plus or minus. Don't forget, when you take the square root of a number, it's plus or minus 2. The reason that is, if I plug in a negative 2 and square it, it's a 4. If I plug in a positive 2 and square it, it's also a 4. And there we go. That should help with problem set 18.